automatic based, molding process are kind of fully automated molding process. Okay. Yeah. So automated, tap laying machines are kind of fabrication machines operate by dispensing a pre-bed tap onto the open mold following a programmed plan. Typically it has kind of X, Y, Z heads. It can move all the way to wherever you want, like three directions. Okay? And of course, the principle is same, but here we don't use short fibers. Instead of short fiber, we use some continuous fibers. Okay, and the continuous fiber will start to, reinforce into the pre-fiber. The thermoset resin. Okay, so the fibers sometimes, they used to get impregnated with the thermoset resin, and it is used as a pre-fiber. Okay, and then thereafter, all this process are same. Giving time for getting attached with that polymer layer, and then you can have some rollers or kind of some pushers where you can have those kind of homogeneous distribution of all those three beds on the first layer of the thermoset polymer. Okay? And then yeah, you can apply some kind of like a temperature to have a completely cured product. So one of the process called filament winding. Okay, and if you see the process, first of all, the resin used to get impregnated with the continuous fibers which are wrapped around the rotating mandrel, which is acting as a mold for your product. Okay, that has the internal shape. The rotating mandrel has the internal shape of the desired fiber reinforced product, and the resin is then cured and the mandrel is removed. Okay, the mandrel means rotating mandrel will be removed at the end, actually, once the product is cured. So the mandrel usually it acts as a mold. Okay, and the fiber rovings. Rovings also you can use, or you can use yarn also. Okay, which are pulled through the resin bath immediately before it is being twisted or wound in a helical pattern onto the mandrel. This pattern can be of different. I'll show you some of the videos what is pattern. And then this operation is repeated to form the multiple layer or the additional layers to have this desired either thickness or the width of your product. Okay. So this is how the total, the machine fabrication machine looks like this. We have fibers, continuous fibers, maybe in the form of wovings or kind of yarn, and that will be pulled towards to the resin bath. Thermoset resin bath, and then subsequently it will be connected to that rotating mandrel. Okay, and this will be collected. The rotating mandrel rotated at certain RPM and angle. Okay, and this rotating this resin impregnated fibers, continuous fibers are twisted onto the surface of this mandrel, and this process used to get repeated for multiple times and different time interval, of course, to have those desired sections. So this is how you can see one of the biggest composite product which was manufactured using filament winding. So this is, you can see a lot of aircraft as well as the space technology, that whatever the outer surface missions, the rocket or any kind of space instrument of missions, or wherever they use this kind of filament winding. Okay. So they have this kind of rotating mandrel pre-mold, and onto the surface of that mold they used to collect all those resin impregnated fiber, and then yeah, that process get repeated for multiple times with different patterns as well as the angle, helix or double helix, etc. And yeah, at the end of the process, after curing, they used to remove that mantle, and then you'll get this kind of big product, filament winding. That is called filament winding, where you get a hollow based structure, usually in the form of cylindrical structures. The video. It's kind of epoxy matrix they use for. Oops. Okay, this video has some issues. Maybe I'll upload it. I'll locate in my hard disk and I'll upload it. You can have a look. So, that's all about this filament binding. So we do have other techniques called pultrusion. So each method has different, geometry of the product you can fabricate. It's not that filament binding you can use it for all the types of geometry of the product. Okay. So similar to that of same extrusion method, which we have seen in the polymer science and technology, okay, like extrusion, we used to have the same kind of process, okay, but at the end, there will be a kind of, kind of mold where it produces only the straight continuous cross-sectional hollow size product. So you'll see some of the product like, yeah. So this is how like slightly different from the expression based geometries, like kind of T shape or kind of U shape, which has like a closely, connected, but it has opened in the one of the side. Okay, so this can be manufactured, fabricated with the help of pultrusion technique. And it was first invented in 1950s for making fishing rods with the help of glass fiber reinforced polymers, epoxy-based polymer. And yeah, and here also they use continuous fibers in the form of rovings, which are dipped into the resin bath, and then again it was put through the shaping die where the impregnated resins are cured. And the sections produced are reinforced through their length by continuous fibers. As a result, they'll have a very good strength as compared to the extrusion based one, because extrusion you cannot use those continuous fibers. And like extrusion, the pieces have a constant cross section whose profile is determined by the shape of the die open. Okay, and yeah, the cure product is then cut into the different section. Whichever the length you would like to have. So the beauty about is that at a time you can have different types of continuous fiber. Rovings. One may be of rovings, one may be of yarn, etc. So altogether they'll be. Together they'll be. Combined in the form of certain. Pattern as well as different angle like helical pattern or kind of double helix, etc. Okay. Again that altogether gets impregnated with the resin path. Again that that travel towards to the pre-dye format where it has the partially cured your fiber and the resins, and again that will be passed towards to the permanent dye where you are going to give a permanent size for your product. Again, thereafter you have a puller rolls where you can pull your the prepared product, and then there you have a knife or the saw, and you can cut wherever the length of the geometry or the length of the product you would like to. So this is some of the, again the same scheme, like you can see, and these are some of the examples of this pultrusion based process. And we do have other techniques called pull forming. Okay, it's as same as the pultrusion. And pull forming has some sort of kind of post-processing steps or kind of some additional steps you are going to carry out once the pultrusion is completed. What is that like? Once the pultrusion is done, and if you want to have this kind of curved product or kind of slightly tilted version of your product, so you have like this kind of rotating table or kind of wheels. Once the shaping is done from the pultrusion process, which means it's kind of 90% cured, still you can give permanent shape. Okay, before cutting that product or before giving it to the permanent shape, permanently pull to the room temperatures. So once the shaping is done, 90% of the 90% cured product, then this product is undergoing this kind of die actually, okay, which has which rotated for certain RPM. So through that you are going to bend your sample out of the product, okay, and then subsequently you're going to cut this specimen. So by that way you will have this kind of curved section or kind of geometry of your product. So that is called pultrusion. Sorry, pull forming. So now here the thing is that the interface is very important. Okay? Interface means the how much interaction or the distance is there between your fiber and the matrix. Okay. So for example, you can see here almost there is no space between the the fiber and the matrix reinforcement. Okay. But of course, if you take them under the microscopy, I mean, you can see how much the distance between the fiber and matrix is. There is a distance, of course. So that should be as, minimum as possible, so that you can have better interaction between the fibers and the matrix or any kind of failures. Okay, could be a particulate or fibers, or could be of some nanoparticles, etc. Okay? So there is always an interface between the constituent phases in a composite material which exists. Okay, and that should be a minimum. Of course, if you have a very good bond, I mean interaction, then that interface should be as minimum as possible. Okay? We have some chemistries like same as like water and oil. So so do you remember the concept like oil resistance of acrylic rubber, nitrile rubber? Sorry, why it has I mean oil resistance? Do you remember that concept?
So due to polarization, non-polar plus polar, I think.
Yeah,
Yes,
yeah.
Like dissolves, uh, unlike dissolves, repels, like dissolves,
Exactly,
what
repulsion here.
that
Repulsion. How repulsion will happen if two guys have different charges or different characteristics? That means they cannot mingle each other. Okay, but here, I mean, sorry, oil resistance, they have a repulsion force. But here, if you want to have a very good interface, actually, you need to have very good interaction, not the repulsion. So rather repulsion, you should have very good. Interactions between the two phases. So that means your two phases should be same action. Say, for example, if you are taking the polymer-based matrix, your fiber should have this hydrophobic or kind of something like, non-polar based behavior. Okay, because most of the polymers are carbon and hydrogen, and they are non-polar in nature and hydrophobic. So fiber, if you see, they may have some biomolecules, or they may have some sort of oxygen, oxidized format. So as a result, they will possess some sort of slightly polar in nature. So, so if you mix polar and non-polar, will it miscible? No, they cannot mix each other, because they will, oppose each other. As a result, the repulsion force will dominate. So here, so if you want to, what's happening here? Yeah. Yeah, if you want to develop very good interface, you should select such that, I mean, they should both should able to interact, each other, or they should miscible each other. If you are taking polymer based matrix, the fiber, your fiber surface should have been modified with the help of any kind of organic molecules, or kind of some oligomer or polymers. Then only you can have, very good interface, or you can have very good interactions between your two polymers. You might have, you can go back to my paper also, what I was discussing with you the other day, like hydroxyapatite, which was surface coated with some polypropylene glycol, right? I remember. Do you remember? Which was, exhibiting better properties than that of the unmodified hydroxyapatite fiber. So here I was discussing the mechanical properties, right? Yeah. So this is typical strain curve, which was obtained by using a universal tensile testing machine. And you have a TPU means thermoplastic polyurethane, and you have a 4 different nanocomposite. NHA means hydroxyapatite nanoparticles, and PPG NHA means polypropylene glycol modified nanohydroxyapatite. Of course, ETP means except GPU, and ITP means in situ prepared composite. Okay, you can see here the ETP and which was unmodified one, because this is polar and this is non-polar. You can see, of course, there was improvement in the properties, but it was not that obvious or the significant. But if you see the polypropylene glycol modified nanoparticle, again, once after modification of, they have we have incorporated into the matrix, and then you see how much the property is dominating, okay, which was significantly higher. This could be of around 13 MPa, and yeah, you can see modified filler is giving around 18 or 17 MPa. So you can see how much, how the interface is playing a key role here. So yeah, that's it about the kind of polymer based material. Maybe I'll refer some of the papers in the next class, like exactly how the chemistry is involving, how to modify the surface. Okay. Although it is very superficial for you guys, like explaining PPG on the surface of hydroxide. So how exactly the OH is interacting with this PPG, all this maybe we can discuss in the next class. So yeah, if I get into this topic again, we'll be confused with that polymer based. So if you have any doubt, we can discuss now, and maybe we'll have some rough discussion. I mean, the overall discussion about the subject later on. Yeah. Okay, so far, do you have any doubts on this session or the previous session? Something?
So will it be possible if you share the PPT with us?
Yeah, absolutely. I forgot to share. I just remembered before the class. I'll do it now.
Okay.
I was sharing a lot of stuff, but videos and all. I didn't share the PPT. Sorry. Because you have a quiz also, right? On Friday.
Yes, sir. Fifth, I guess.
Yeah. Okay. So we'll have some other discussion like. So what are the processing techniques you know in metals? Say for example, if I want to fabricate some stuffs out of metals or alloys, what are the fabrication things you know?
So is it basically metal forming like rolling and extrusion processes?
Okay. What is extrusion process?
So in
Cold rolling.
extrusion,
Yeah.
yeah, hot rolling extrusion process in which there are two types, I guess. Injection. One is for injection, and it is for forming pipes, and the other is for thin film forming, in which we use vacuum as well.
Okay. And have you studied about the friction stir casting, etc.? No.
So not yet, and I guess Foundry was also cancelled.
Okay.
Foundry technology.
No, I'm just asking. Accordingly, I'll have to keep some extra slides. I have included some of the slides. Yeah. We'll see from next class all this thing. Okay. Anything else to discuss? Lala Mohan Kumar is here? No. He was emailing me that he wants to drop now, but I mean, the time is over now for dropping. So, Anand, you tell him that he has to contact his supervisor, faculty advisor. Okay.
Okay, sir.
Okay. Yeah. That's all today class. And if you have no questions, we can close this session. So we'll start mathematics composite from next class. And I'll upload some of the videos as well, and of course PPT.
Thank you, sir.
Yeah, thank you. Bye.
Thank you, sir.
Thank you.